Hey there, fellow coders. Welcome to the second video in our Running Airflow on Kubernetes series. I'm Praj, and today we are going to talk about something essential for any serious development workflow: continuous integration and continuous delivery, or CI/CD, specifically for our Airflow codebase. In this video, we'll set up a CI pipeline using GitHub Actions, enforce code quality checks with pre-commit hooks, and use ruff for lightning fast Python linting. Let's jump right in. First off, why do we even need a CI/CD for Airflow? Airflow DAGs evolve constantly, and a single broken DAG can stop entire workflows. By automating tests and enforcing code standards, we catch errors early and keep our codebase consistent. With GitHub Actions, we can make sure every commit is vetted before hitting production. For this video, we are going to concentrate on Airflow DAGs, and we leave out writing custom plugins for a later video. What is pre-commit? Git provides a way to add hooks between different actions. A lot of companies I've worked with always had pre-commit hooks. As the name suggests, they are basically scripts that run before the code gets actually committed. That looks for easy to catch issues and make the pull request review process easier. If issues like formatting, linting, and types get caught in the checks, then the developer reviewing the pull request only has to deal with understanding the logic and the readability of the code. I might be simplifying this a bit, but according to me, the earlier you catch the errors, the faster the development lifecycle would be. Now let's talk about pre-commit, the tool itself. It is a framework for managing and maintaining multi-language pre-commit hooks. It is written in Python and it is pretty flexible. We are going to look at installing it and configuring it. Then we are going to run ruff linting and black code formatter on our Python code. We can use ruff formatter as well. I am just adding another tool to make it easier to demonstrate using different checks. If you're working on Python projects, I would also include mypy as a pre-commit hook check. Let's first install the pre-commit tool, and for that we would need to run brew install pre-commit. Once you have pre-commit installed, we'll need to add a pre-commit config file. Now pre-commit actually expects the config file to be in named like this. It should be named .precommit config.yaml. Once we have this file, let's add ruff and black to this pre-commit hook. As you can see over here, we need to add the repo for pre-commit as well as any arguments that we need to pass to the pre-commit tool itself. After saving this file, you'll have to run pre-commit install, which would end up copying the scripts inside the git repo. So let's do that. Pre-commit installed. Whoops. Let me run it like this. Pre-commit install. Okay. So if you're running this for the first time, you're going to see a different output where it downloads the repos and then it would copy over the scripts inside this folder. So if I do like a ls that folder, or actually not ls, if I just open the hooks, you can see that it's actually installing pre-commit and then it's picking this configuration automatically. Nice. Now that we have pre-commit installed as well as our git hooks configured, let's try to test this. What I'm going to do is I'll create a trial commit. So git checkout branch, then trial commit. And over here, I'm going to just basically break some formatting so that we can see the script actually failing. Let's see, what can I do over here? I'll have to do something that would make it a valid Python file, but still break formatting. So here we go. Nice. Git diff. You can see the difference now. Now let me add status. Seems I had a lot more files. Let me reset the ones which I don't need. Reset locals, auxiliary worker, git status. Nice. Now I only have one file to look at. So I'm gonna try and run a git commit. Trial commit. As you can see, that black failed because the files were modified by the black hook. Let's see what it did. So if you do git status, you can see that we like black modified this file. Now let's do a git diff. You can see that it automatically formatted, and also it fixed one of the other files which I like one other place which I had an error. Error in formatting. Okay. So what I'm going to do is git add DAGs, then test parallel, git commit. And this time it would go through because black already formatted it to be correct. I'm hoping this demo showed you the power of pre-commits and gave you a glimpse into the possibilities of making workflow faster for your team. We're going to move towards a CI check on GitHub, where we'll run a DAG validation check. For setting up a GitHub workflow for doing DAG validation, we'll have to create a folder called GitHub Workflows. So it's supposed to be under GitHub. So your base folder, there would be a .github folder created, and then you would have workflows under that. And let's look at the workflows we have written up. Now this is for DAG validation. What this is doing is it's going to run on all the branch pushes, and it just checks out the code in the repo, then sets up Python on the Ubuntu machine, and then it's going to install all the required tools. And once that's done, it's going to run this Python file, which is called test dagimport.py. Let's look at what that Python file is actually doing. So all it does is it uses DAGbag class provided by Airflow and passes in the DAG folder, which in our case it's going to be DAGs, and then it just imports all the DAGs and sees if they can be imported or not. Now I went ahead and ran an example. So given the requirements which we had, which were pandas, request, pyaro, then these two Apache Airflow packages, one of the tags which we had actually dealt with Postgres, and we didn't have any dependencies added in here because Amazon's MWAA automatically adds that dependency behind the scenes. Now, because we are not running on MWAA anymore, and this is actually running on GitHub itself, what we'll have to do is we'll have to explicitly add that import. Else, if you don't add it, you would see something like this. Now let's go back in here and add that import. Airflow, Postgres. Okay, get status. Okay, I guess. Cool. What I'm doing is I'm just it seems that I have some conflicts in here. If I do get status, I have conflicts in Airflow. This Okay, I don't need the constraints anymore, so I removed it, and then I'm going to do a git add, then continue with the rebase. Cool, nice. Now we have rebased on main. I'm going to create a new branch. Now this, I'm giving it a name, adding Postgres dependency. Cool. Now let's go ahead and add this again. Here we go, git status, add Airflow requirements, git commit, adding Postgres dependency. Let's go back to Firefox again. Go to the commit. Now this is like a different branch. Let's see what now that we have added a workflow, it would show up over here as a check. It's installing the dependencies. It's going to take a couple of minutes, so I'll be pausing the video and I'll continue once. Even with the installation of the dependency, it is still failing with a similar error. This error seems a bit different from the last one though. This makes me think that we actually need the constraints in the requirements file that we got rid of. I'm going to add the constraints back in. The importance of constraints when dealing with a complex system like Airflow is that it makes sure all the versions that pip installs are compatible with one another. In the constraints link, I'm going to keep the Python version to be 3.11 as that's what we use in the GitHub workflow. Now let's go ahead and commit the changes. After pushing them, we can take a look at git actions run. Awesome! This time all the DAGs passed. As we can see, adding this check already saved us from shipping wrong dependencies into production. We can add more unit or integration tests if needed and run them in GitHub Actions. Now that we have CI pinned down, let's think about how CD would work in this case. We already have configured git-sync in our last video. In case of Airflow on Kubernetes, git-sync will be doing the CD for us. There are two ways in which git-sync works on Kubernetes. One with persistent storage, where all the pods would share the same code, meaning the code would be pulled once, once every cycle, and all the pods will have access to it. This is done through using persistent volumes on Kubernetes. The other option is using non-persistent git-sync. In this case, web servers, workers, and schedulers all have their own copy of DAG code. As we are using Kubernetes Kubernetes executor, each task will run git-sync as an init pod, meaning whenever a worker task is started, it will have the latest code available at that instant. I'm not going to go more into which one would be the best, as each have their advantages and disadvantages. I'll be diving a bit deeper on this topic when we talk about production best practices. If you found this video helpful, please like, subscribe, and drop any comments in the comments section below. In the next video, we'll be looking at logging and monitoring with a local Kubernetes setup. See you next time. Have a great week and keep learning.